Talk about a day in the life of a developer. How do we move code from development to production without losing control? So, first, let me introduce myself. My name is Jason Epstein, and I'm a senior solutions engineer with Mirantis, and I consider myself a passionate containerist. And I call myself that because I think basically everything should run in a container. Okay, there's probably some exceptions. Actually, there are some exceptions. But anyway, at Mirantis, we provide a secure enterprise grade distribution of Kubernetes, and along with some tooling around it that helps developers and organizations basically ship code faster. That's our mantra. Today, we're going to cover the secure supply chain for container development. So first of all, what is the software supply chain? So the software supply chain includes everything that is necessary to deliver our applications into production. So that includes everything that goes into the container, the application code, the libraries, and any third-party tools. It also includes a container host operating system, so maybe one of the Linux flavors or Windows, and the container runtime, as well as any orchestration tools like Kubernetes. So there's recently been a huge number of attacks in software that have compromised well-known software company supply chains. Some of these have allowed attackers to gain access to sensitive information and systems. They do this by injecting their own malicious code or backdoor capabilities into third-party systems, which then get incorporated into your software products. This has become especially challenging to combat as the software supply chain has become extremely complex. It's a completely tangled web of different software components, and they're all needed so we can deliver the required functionality and application requirements. But this complex web allows developers to build applications faster and with lower effort, and it uses pre-existing tools and libraries that come from a variety of sources. But it carries an inherent risk. So what is the risk? Well, the security challenge, unfortunately, comes from this much-needed flexibility. It allows an attacker to potentially inject an infected library or tool into the process, either during the development process or later when components are updated. So we think of it as the sources of risk, besides the kernel, the runtime, and the orchestrator. The components that we think of it as the components that are generally included in a container. So these are usually come from three different sources. So first of all, upstream libraries and tools. These are the tools and libraries that have been developed by the open source community and made available on GitHub or other repos. And this category happens to be our highest risk. We have a tendency to trust the open source community software because we assume that there's lots of eyes on it that'll pick up anything malicious. But the reality is that there's been a number of direct attacks on these open source repositories, or more subtle attacks where code has been slowly injected through the normal contribution process and has gone undetected for a long time. The next section is vendor libraries and tools. So these include libraries and tools that have shipped with the OS, the runtime, or other vendor-delivered software. This category is probably, and I emphasize probably, the lowest risk category, as the code is usually scanned and verified through the vendor supply chain. Application code is the last one. This is usually the in-house written code and libraries, but could also include upstream open source applications that have been adopted. The risk here is that this code is often considered trusted and doesn't get the level of scrutiny it probably should. While the risk has always been there in the traditional software supply chains, it's typically been mitigated by software companies performing detailed security checks and extensive testing on their software before shipping it out. Our more recent development processes, however, have become more agile, which is great news. But we're using containerized applications that can be built, tested, and productionalized on the fly, using technologies like Docker Compose or Helm to define complex application sets. And we're also using Docker files to define everything that is needed to automatically build each container. And we're using CI/CD solutions like Jenkins to build, test, and push applications to production much faster. However, this has significantly increased the number of places where vulnerabilities can be introduced. So in order to mitigate the risk of someone injecting unwanted code into our applications, we need to change the way we think about trusting our code. Essentially, we need to become more paranoid. We can no longer trust anyone in the supply chain and need to be able to verify and scan everything at every stage of the process. In addition, once we have verified the code and built the images, we need to verify the images and securely store and sign them so we can be sure the images we are storing are the ones we approved. There's a chain of trust that needs to be created around these artifacts, and we need to be able to prove their provenance or chain of trust in order to feel safer. Finally, we need a way to ensure we can only run the images that we have approved, and that images that have not been through the approval process cannot be executed in our production environment or in any environments that are important or sensitive. So we're trying to get to a software supply chain where no one has a chance to sneak anything in that we don't want, whether intentional or unintentional. Let's now go through what we need to do to make this happen. So we're looking to ensure that our images are scanned, tested, reviewed, and verified. So let's drill into that. So first of all, for images, we can build code with Jenkins, as we've always done. But once we have those images, we need to make sure that there are no vulnerabilities. We can scan them with a secure registry like Mirantis Secure Registry, which is formerly known as Docker Trusted Registry, or one of the other secure registry scanners on the market. Then, once we know we don't have a ton of vulnerabilities in our image, we can move into the testing phase. This is where we run tests with Jenkins, as we've always done, and run our unit tests, integration tests, and anything else in our testing suite. Once we've completed our testing, we can then sign our image, certifying that it has passed our testing and scanning regimen and is approved for the next phase. Then we can ensure that before we run it, we verify that it has been signed. So we know with 100% certainty that this is the exact image we think it is, and it has not been replaced or tampered with. So how do we make this happen? Well, so after we're done building the code, we can send it up to the registry to be scanned. And once it's been scanned and has passed, we can promote it to the testing stage. When the testing suite has been completed, we can take the successfully tested image and have it scanned. It's then checked back into the registry and made available for use in our actual environments to be run in our application. As part of that process, we set restrictions to ensure only signed applications can run. Let's now walk through the steps of what this would look like if we were to use Jenkins for our CI tool, then a secure registry like Mirantis Secure Registry, and a few other tools along the way. So first of all, images that we start with our images, which get built from code with Jenkins and sent to the registry. So we'll start with this example, which is an HTML file that uses Nginx to display it. And we'll make a quick change to, this shows a change has been made to change the title to simple Nginx title. So now we'll commit these changes to the repo, actually this is GitHub. And notice that I'm just using the web UI for GitHub. You can use an IDE and push the code to your local Git repo or to GitHub or Bitbucket or whatever else you're using. So you have your choice of tools, whether to make the code changes and to store the code. But I'm using this as a simple example. So once the changes is committed, Jenkins should pick this up and begin and kick off the building process. So Jenkins will check out the code, build it into a container image, and run its own unit tests. So then it'll then push it up to push the container image up to a registry. This shows the Mirantis Secure Registry (MSR) with the image that Jenkins built pushed into it. This is, let's just call it, this is an old version of Nginx, 1.7.9, which some of you may know is like 5 or 6 years old. So we're going to see some interesting results when we scan it. So now we have to scan it for vulnerabilities, and if it passes, we need to have a promotion policy that pushes it up to the next stage. So the MSR product can automatically scan any image upon push. In this case, we're going to have Jenkins do it. Jenkins will invoke that functionality through the MSR APIs. So it's been scanned, and if we look, we see 24 critical vulnerabilities. Now, that's a lot. I would never run this in production. But again, in all fairness, this is a very old image, and it's very out of date, and I'm just using this image to make a point. So anyway, We can dig into this a little bit further and look at some of the CVEs. We see a number of high severity vulnerabilities. And this is actually useful because maybe we want to see what those vulnerabilities are, because some of them, maybe we already have other mitigations for it, or maybe they don't impact our environment because just it's not applicable to what we're doing. And if that's the case, in this tool, you can dismiss these specific CVEs so that they don't show up in future scans. It's always good to look at what your vulnerabilities are, what it came up with. Anyway, in this case, we have a lot of critical vulnerabilities and even a ton of even more high severity vulnerabilities. So we want to make sure this does not get passed on to the next phase. So that's where we're going to set up the promotion policy. So what we'll do is we will set up a policy that requires that the number of critical level vulnerabilities is equal to 0. The number of medium level vulnerabilities is 5 or fewer, and we'll create that policy. So now let's start over with a new image. This is a much newer version of Nginx. I think this is 1.21, which has just been out a couple months, the latest version of that. And it's a lot more secure, a lot safer. So we'll push that with Jenkins up to the registry again. And now it's here in the registry. And we'll kick off a scan. And now we see there's 0 critical vulnerabilities and two high level vulnerabilities, 2 medium and 2 low. So this is much safer to run. We still probably want to look into those CVEs for the high and medium just to make sure they're not going to impact our environments. But the promotion policy that I set up, and let's remind you of those, where I said 0 critical vulnerabilities and 5 or fewer medium, it passes. So we can move this on to the next stage of our process. We're also going to sign it because I want to make sure that when it gets to the next stage, we can verify the signature and know that this image has passed through this policy and it hasn't been replaced or tampered with. And this is adding a cryptographic signature that ensures image provenance and ensures that the image that you're getting is exactly the image you think it is. So that's the sign. We've signed our development image, and we are now going to deploy it to development. And that's where we go into the testing phase. So that's where we're going to run our integration tests. And if it passes, we're going to sign it again. So the first signature was, say, from the development group. This is going to be signed by the testing group. So we're also going to call a webhook. So that means, basically, when the security scan has been completed, we will call out this webhook URL, and this is just a sample URL where an application which will have Jenkins pull the image, run some more tests on it, and if it succeeds, push it back into the repo. So that's been completed, and now Jenkins is in the middle of those integration tests that we call through the webhook, and that all passed, and now it goes back into the repo and gets promoted. And we're going to do any kind of last reviews if we want to have like security tests running on this. And then finally, we're going to want to digitally sign the image again. And if everything succeeds, we'll digitally sign it and check it back into the registry. All right, so that's been done, and we are signing it, as I said, to be certified production ready. And so now we're not quite done yet. So we're pushing it to production, but we still need to verify that it really is the correct image and it hasn't been tampered with. I can see of a scenario where we've gone through this whole process and maybe we had an image with some malware or some vulnerabilities and it failed, didn't get through. And then someone either maliciously or unintentionally took that image and put it into the production environment. Even though our testing process showed that it was not fit to run there. So that's where we need to do a final verification to ensure that this image really has gone through the required processes and has passed all the checks that we've put on it. And we do that by verifying the signature. And that is something that we can do in our production environment. And this can also be done in your development or production or testing environment. This is a feature of Mirantis Kubernetes engine, and there's other Kubernetes distributions that will do this as well, where they'll run only images that have been cryptographically signed by a set of users or groups. In this case, I'm requiring that all these images have been signed by the developer team, by the QA team, and by the security testers team. All three signatures must be present. If anything is missing, the image will be blocked and cannot be run and cannot be run. So that takes us to our last stage, where it's been deployed to production and the Jenkins pipeline is complete. So now we can go look at our website, and there it is running. And now we know that we have a well-tested and secure application running in our production environment. So I will now take questions. If you have any question, if you can think of anything else, any other questions after this talk, you can feel free to go to www.mirantis.com/contact and submit your questions there. Otherwise, I'll take questions right now.